Okay. Alrighty. Okay, so we're going to start off with reviewing multiplying polynomials. Okay, so the way we review, it's not quite in the order of the final exam, but all the content is going to be the same. So the focus in grade 10 was on binomials times binomials, and then we took that idea and expanded it to binomials times trinomials, trinomials times trinomials, binomials squared, binomials cubed, all that. Like we just ran with it. For grade 11, all you need is binomial times binomial. That's it. Okay, so we went well beyond that in grade 10 because that's what we're required to do. But in grade 11, they actually scale it back. And the reason why is because there's going to be steps before it and there's going to be steps after it. And it's those steps on either side that are going to be the new piece. Okay? So I showed you 3 different ways to do this. So if you're a tic-tac-toer, you're just going to take your binomial, put it on the edge, and you're going to fill in the middle, multiplying as you go. For distribution, you take the first bracket, or either one, it actually doesn't matter, but you take one of the brackets and you separate it up, and into that space beside it, you're going to keep the second bracket together. And then what you did is you multiplied through and you multiplied through. For foiling, foiling is essentially the exact same thing as distribution. You're just not showing any of the work. So what you would do for FOIL is you would put your hand over the +1, pretend it's not there, and then you would multiply the 3x through the bracket. And once you've done that, then you put your hand over the 3x. So you remove that, and then you do the same thing. You multiply to get the next 2. Okay? Now, it doesn't matter which method you do, as long as you're doing it correctly, right? And then at the end of it all, the answers will match regardless of which method you're doing. And on to the next question. The biggest mistake that you guys made with this is just doing those stupid things like 3 times 2 is 5. That was typically the mistake. You did not make a mistake with the process, with the steps. What you did is you made a mistake with the numbers. Okay? So I just wanted to just quickly review the 3 methods. On the exam, it will, question number 1 on your final is multiply the following. That's it. You're going to pick the method that you want to do. Okay? So we're just going to do some examples. Okay? So you are picking and choosing what method you want to do. Now again, okay, the level of difficulty that I'm going to do with you over the next week and a half is the level of difficulty on your final. In class, we went way, way harder with this. We are simply now practicing the skills that you will see in grade 11. We are not going back and reviewing the entire coursework. Okay? So, question number 1 is a monomial times by a polynomial. So this is actually a grade 9 question. Okay? So in grade 9, you mainly just dealt with monomials. So 3 times 2 is 6. What is x squared times x cubed? When you're multiplying x's, what do you do with the powers? You add them. So 2 plus 3 is 5. 3 times negative 3. Now be careful here. x2 times x1 is x3. And then 3 times 6 is 18. And I just stick the x squared on the end. And that's it. Okay, grade 9. Here's another one from grade 9. So again, it's a monomial times by a binomial. Same thing here. A monomial times by a binomial. Okay. So 3x times 2x is 6x squared. 3x times negative 4 is negative 12x. Now here's where you need to be careful. You're going to multiply through by negative 5, not just 5. So negative 5 times 3 is negative 15x. Negative 5 and negative 2 is a positive 10. Now, what's different on this one is that we have ended up with some like terms. So when you do end up with like terms, you are required to take them down and add them. So we've got 6x squared. So this is where if you're struggling, you're going to use your calculator. So what you've got here is negative 12 subtract 15. Or you could think of it as negative 12 plus negative 15. Either way, it's negative 27. So that is what we're looking for the final answer. Okay? So the first two questions there are straight up grade 9. Okay? So in grade 10, we went into binomial times binomial. Okay? Shh, guys. So option number 1 is to do a tic-tac-toe board. So you're just going to write down the method that you prefer. Or you can do distribution. So separate up the first bracket, keep the second bracket together. Or you can skip the work entirely and hide the 2, multiply, hide the 3x, and multiply. And then you would go straight down to this step right here. So if you're doing tic-tac-toe, you just go square by square. So 3 times 9, x times x. Next square, negative 4 and 3. Write the x in. Next square, 9 and 2. Stick the x in. Last square, negative 4 and 2 is negative 8. Remember, you are multiplying. So negative 4 times 2 is negative 8. If you're doing distribution or FOIL, so 3x times 9x, 3x and negative 4. Next one, 2 and 9x, 2 and negative 4. You end up with the exact same 4 terms. It's just that these 4 terms are in a square, these 4 terms are in a row. But you will have like terms. Now, distribution and FOIL, your like terms will probably be somewhere in the middle, whereas tic-tac-toe, your like terms will always be on a diagonal. If they're not on the diagonal, you've done something wrong, okay? But they will always be on that diagonal. So the final answer, so again, negative 12 plus 18 is 6. And again, if you're struggling with those integers, please use the calculator that's going to be on your desk. You don't have to do this in your head. Okay. How do you deal with squareds? What's the very first thing you do when you see a squared? It's not multiply. What do? What does squared mean? Times it by itself. So when you see a squared, the first thing you do is you write out the bracket twice. Now we go through and do our method, because now we have a binomial times a binomial. So 5x minus 3, 5x minus 3. Okay. So 5 times 5, 5 times negative 3, 5 times negative 3, negative 3 times negative 3, guys. So again, if you're doing it by distribution or FOIL, those 4 terms will just be in a row instead of in a square, but we'll all end up with the same 4 terms. So we've got 25x squared, negative 15, and another negative 15 are negative 30, and then the 9 on the end. So like I said, in class, we did way more than that, but that is the depth of understanding I need you to be at. Okay? The hard part of this final is keeping all the concepts straight, right? We've got 13 different concepts that we're going to be testing, and so it's keeping all 13 straight in your head. It's not getting to the level of difficulty that we did before, it's just keeping all of that straight. Okay? Okay, factoring. So we're going to take a little side trip here with this. So the next couple of slides are not what is on the final. The next couple of slides is just going back and relearning the methods of factoring. The key thing with factoring is that you need to be able to look at a question and know what method to do. You will not be told, this is a greatest common factor, this is a trinomial, this is a difference of squares. You will not be told that. The question will simply say, factor the following, and there'll be like 6 questions underneath it. You need to know what methods to do when. So before we even get back to that, we're going to go back and review each of the methods. Okay? So GCF, first thing about it, it's always your first step. Now, not every question you can do a GCF on, but it's always something you check for first. Because if you can do a GCF, you must do it before any of the other types of factoring. So if you can't do a GCF, that's fine. You just go on to the other types. But if you can do a GCF, it must come first. Okay? So the method for it was we found the monomial. And the monomial was the largest number and the smallest letter. And then we went ahead and divided that into our polynomial, and we got out the second bracket. So, a couple examples. So, checking for GCF. What is the largest number that goes into 15, 9, and 30? 3. Okay. Do they have an x in common? Yes. What is the smallest number of x's they have in common? 1. Okay. So you take the biggest number and the smallest letter. This is what we refer to as the GCF, or the greatest common factor. Once you find that, then you take each term and divide by it to get the second bracket. So 15 divided by 3, you have 3 x's, you took 1 out. 9 divided by 3, you have 2 x's, you took 1 out. 30 divided by 3, you have an x and you took it out. Now these questions were all worth 2 marks each. 1 mark for each bracket that you found. Okay, so 1 mark for the first bracket, 1 mark for the second bracket. For this next one, what is the largest number that goes into 36, 24, and 18? The largest number. 6. Okay. Now, if you struggle with finding that, my advice to you is go to the smallest number in the list, which in this case is 18, and think of all the different ways to multiply to get 18. So 1 times 18, 2 times 9, 3 times 6. This number has to come from that list. So just use guess and check. So 18 doesn't divide into 24, but it would divide into 36, so you can't use 18. 2 goes into all of them. 9 does not go into 24. 3 goes into all of them, but 6 would be the biggest one that goes into all of them. So 2 would work, 3 would work, but 6 is the biggest, and you always want to pick the biggest. Okay, can you take out a letter? No. This one has an X, this one has an X, this one does not have an X. So if it does not have an X in common, you cannot take it out. So in this case, your GCF was just the 6. That's it. So you divide everything by 6. And you get that. So that was GCF, okay? Trying to find that number, okay? Questions on GCF? Okay, next type of factoring we did was trinomials. So in grade 11, trinomials are going to be called quadratics. And quadratics are the cornerstone of all math in high school. In 20-1, you're going to do 10 units. Of those 10, 6 of them boil down to quadratics. So if you can't do quadratic factoring, you can't pass that course. Because 6 of the 10 will boil back to this point right here. In 20-2, 2 of our 7 units boil back to quadratics. Now fast forward to 30-1 and 30-2. In 30-2, half of the course boils down to quadratics. In 30-1, like 90% of the units boil back to a quadratic. It is a cornerstone concept. So if you struggle, so here's the thing, most grade 10ers can do trinomial factoring or quadratic factoring, it just takes them a while, which is fine. You've seen it for a week and a half of your life. By the time we get you in grade 12, you'll have spent an entire extra semester doing quadratic factoring, and you'll be that much better at it because you'll see it constantly throughout. Okay? So all of these questions, all of them, have to look like this. So something x squared, something x, and then a something on the end. So it's called trinomial because there's 3 terms, ax squared, bx, and c, but it's not just any 3 terms. It has to be x squared x number. Now, here's the catch. There's 2 types of trinomial factoring. There's the ones where a equals 1, and they're the ones where a doesn't equal 1. The ones where a doesn't equal 1 are harder to do than the ones that where a does equal 1. Now, when I taught this to you, I taught you the 2 methods of doing this. That is just one way of doing these. There are many, many ways to do quadratic factoring, like 6 or 7, okay? So if you don't like the way I show you, go on Google. Just type in how to do a trinomial factor, and you'll see a bunch of videos showing a whole bunch of other different ways. So if you really don't like the way I show you, go and look for something else. Because at the end of the day, I don't care how you do it as long as you get the 2 brackets. Okay? So let's do the first one here of a equals 1. So we can see here that there's a 1 in front of that x squared. Whereas here, we can see that the a does not equal 1. So now you're going to have to go through that check. Do you have a 1 in front, or do you not have a 1 in front? For the ones that have a 1 in front, you are going to set up a little magic square. So you're looking for 2 numbers that add and 2 numbers that times. The number that adds is always the middle number. And the number that multiplies is always the end number. So add to get 14, multiply to get 33. Okay. You are trying to find 2 numbers that when you add them, you get 14. When you times them, you get 33. Okay. There are infinitely many numbers that add to get 14. Okay. But there's only one number that will multiply to get the 33 and the 14. So focus on the 33. What are the only 2 numbers that multiply to get 33? 11 and 3. Does 11 and 3 also give me 14? Yes. Okay. So focus on the timesing, and then the add will come. Okay, draw your 2 brackets. Whoops. So what we have here is x squared. So in the first spot in each bracket, you're going to go x times x. because x times x would take me back to x squared. And then all you have to do is bring down the plus 11, bring down the plus 3. That's it. Now, if one of you wrote x plus 3, x plus 11, and somebody else wrote x plus 11, x plus 3, you're both right. The order of the brackets doesn't matter. It's just what is inside them that counts. Okay. Again, all of these questions are just worth 2 marks each. Okay. Okay, so unfortunately, when a does not equal 1, these are not the same. Now, this is where there's a whole bunch of different ways to do these questions. The way I showed you guys in class was to do tic-tac-toe in reverse. That's the way I taught it to you. This was the method we picked. So, when a does not equal 1, you cannot do this method. At least I haven't shown you how to make it work. Okay? It is possible, but I just haven't shown it to you. So, we have to set this up. So the 6x squared always goes in the middle square. Okay. The plus 15 always goes in the bottom right. Now what I like to do is use a highlighter to highlight my diagonal. And the diagonal is going to be the number in the middle. Now, we do that diagonal last. You leave the diagonal till the end. Now, you are probably going to screw this up at least once or twice. This is going to be a guess and check game until you find the right combination of numbers. The more you do, the better you get. So that's what I'm saying. By the time you get to grade 12, you may not even need to set up a tic-tac-toe board. You can probably just jump straight to the answer because you'll be that much stronger at it. Okay, but for now, we're going to go through the process. So let's start with the 6x squared. There's 2 numbers you could try that multiply to get 6. What's one of them? 3 and 2. What's the other combination? 1 and 6. What do you want to try first? Do you want to try the 3 and the 2 or the 1 and the 6? Probably the 3 and the 2. It's probably what most of you would guess. Now jump over to the 15. What 2 numbers could you try to multiply to get 15? 3 and 5. What's the other combination that might work? 1 and 15. Now, do you remember the tip I gave you? If we want to try 3 and 15, should I put the 3 here? No, because did you ever want to line up numbers that were the same? No. So I'm going to try 5 and 3. What are the only 2 numbers that you can line up that are the same? 1 and 1. Okay. You also don't want to line up multiples. So you don't want to line up a 3 with a 6, a 2 with an 8. Okay. You want to keep those things separate. So if this works, yay for us. If it doesn't, we're going to have to manipulate our numbers. So now what we do is we see if we can do this middle. So we multiply. 3 times 3 is 9. 2 times 5 is 10. Does 9 plus 10 give me 19? Yes, it does. So we did it right. So you must write the brackets. So 2x plus 3 and 3x plus 5. Okay? Okay. So another one here. Again, a does not equal 1. Now what makes this question a little trickier, guys, stop it. You haven't stopped for the entire class. If you're not interested in being here for the review, don't let the door hit you on the way out. Honestly, I'm done. So again, because a does not equal 1, what makes this question harder is the fact that this is subtract. So we have negatives to deal with. So if you struggle with those integers, you're going to use your calculator. Okay? So start off the same. The 12x squared goes in the center square. the negative 3 goes in the bottom right, and the diagonal is the center number. And we leave that till the end. Okay, it doesn't matter whether you do the 12 or the 3 first. So actually I want to start with the 3 this time. And the reason why is because there's lots of different combinations to multiply to get 12. There's only one combination that multiplies to get 3. So don't worry about the negative for right now. Let's just put in 1 times 3 is 3. So 1 times 3 is 3. Don't worry about the negative. Okay, we'll deal with that in a second. Now, let's think about 12. You've got 1 and 12, 2 and 6, 3 and 4. Let's talk about the 2 and the 6. You would not want to go 6 and 2 because 6 would then be lined up with the 3 and that would not work. So if you wanted to try 2 and 6, we would have to do the 2 here and the 6 there. So let's just see if that works. So if I go 2x and 6x. Again, I haven't done this beforehand. I'm just seeing if it works. So 3 times 6 is 18. 1 times 2 is 2. Will 18 and 2 ever give me a negative 5? No. There's absolutely no way. So 2 and 6 didn't work. What's the other combination now I could try? What should I jump to next? 3 and 4. So again, for the 3 and the 4, should I put the 3 here? No, because I don't want to line up 3s. So I'm going to go the 4 here and the 3 there. Now, if this doesn't work, my only option is 1 and 12. Okay? So 3 times 3 is 9. 1 times 4 is 4. Now, right now, 9 plus 4 is 13. But I can manipulate it to get out the negative 5. So using your calculator or your brain, whatever's turned on at this current moment in time, should you go negative 9 plus 4, 9 plus negative 4, or negative 9 and negative 4? Which one should you do? Negative 9, because you want to get out negative 5. Okay, now, this is where some of you are screwing up, and technically it doesn't matter. However, because I have taught grade 11, if you do what you guys were doing when we did this, you're going to make your life more miserable. We need to pull this negative out. Now, technically, don't write this down. I'm going to do it in erasable ink. Technically, I can pull that negative either up here to the x or here to the number. Never pull it to the x. You will see, technically it's a right answer. Like, I'm not going to mark you wrong, but what you're going to do in grade 11 as the next step, it is substantially harder to do if you make this negative. If you bring it this way, you're going to make your life a whole lot harder in grade 11. So just always, if you have a negative, bring it out to the number. Do not bring it to the x. It will just make your life that much easier. Now do a quick check. Is negative 3 times 1 now negative 3? Yes, so that negative took care of itself. So your brackets are 4x minus 3 and 3x plus 1. Okay? That's trinomial factoring. Okay? It's the trickiest of the factorings. The last one we have is difference of squares. Everybody loves difference of squares because they're so easy. So, in order to do difference of squares, your question must have a very specific appearance. It must have, hold on, only 2 terms. It must have a subtract sign. And each term must be something that is squared. In class, we called them perfect squares. So does the first one match the condition? Does it have two terms? Does it have a subtract? Can 9 and 16 be written as something squared? Yes. So all we do is we just go straight to the brackets. So you take the first term, and we're going to put it into the first spot. What times what is 9? 3. What times what is x squared? Okay, next number is 16. We're going to do that one in the second spot. What times what is 16? 4 times 4. And again, it has to be like the square root of 16. And then what did you do with the signs? Do you remember? Minus and plus. And that's it. You're done. Take your break. Be careful of the cord. Do not trip on it. Okay, so let's just do one more of these difference of squares. So again, you just want to check to make sure they're matching the condition of the question. So this has two terms. This has a subtract sign. And 25 and 169 can both be written as a perfect square, as well as y to the fourth would be written as y2, y2. What would x to the sixth be written as? x3, x3, because remember, you add the exponents, you do not times them. So now again, the order is important. Okay, so whatever comes first, that is what happens. So if this is first, it has to be first in both brackets. If you get the order wrong, it actually is a wrong answer. Okay, so 5 times 5 is 25. Y squared times y squared is y to the fourth. If you don't know your times tables very good, like 169 is kind of a larger number, all you do on your calculator is go square root 169. So on your calculator, just take the square root of it, and you will get out 13. And then y to the power of 3 times y to the power of 3 does give x. Thank you. I'll just do this. Again, x3 times x3, remember you would add those exponents. 3 plus 3 gives 6. And then finally, for signage, you make 1 a plus and you make 1 a minus. Yep. No, as long as you have the numbers in the right order. Yeah. Okay, so what Alex was asking was, I made the first one the plus and the second one the minus. If you made the first one the minus and the second one the plus, that's fine. But you have to have the 5y squared in the first position and the 13x cubed in the second position. That is non-negotiable. Okay. Okay, so those were the three methods of factoring. So we just reviewed that over about a 20-minute time period. That is not what's on your final. This is what's on your final. The final will just say factor. This is what's on your final. So you will not be told which method to do when. So if you put your hand up on the final, number one, I'm not answering you. The only questions I answer on the final is if your calculator is not cooperating. If you put your hand up on the final on this question and say, I don't know which method I should do, I have to walk away from you. I can't even give you a push, okay? Because if I give you a push, I'm telling you what method to do. So it is a two-step process. The first thing you do every single time is check for a GCF. If you can do it, great. If you can't, doesn't matter. The second step is you check for trinomial or difference of squares. Okay? So 1, 7, 10. Is there anything other than 1 that you can take out of 1, 7, and 10? Nope. X squared x, no x. Do they have an x in common? No. So this is no GCF. You still have to check for it, but you cannot do a GCF on this one. That's fine. You just now go on to second step. Does this look like a trinomial or does this look like a difference of squares? This is a trinomial. Okay, so it's a trinomial. So a equals 1. So we're going to do our magic square. So they have to add to give the middle. They multiply to give the end. So focus on the multiplying. What two numbers, when you multiply them, you get 10, but if you were to add them, you'd get 7. 5 and 2, yeah. So go straight to your brackets. So x squared is x times x. And then you just plunk in the plus 5, and you plunk in the plus 2, and you've just earned 2 marks. Okay. Okay, next one. Again, first thing we do is check for GCF. Is there any number that goes into 4 and 81 other than 1? Nope. This one has an x, this one does not have an x. So can you do a GCF? No. So again, you still check for it, but you can't do it, which is fine. We just go on to the second step. Does this look like a trinomial, or does this look like a difference of squares? Which one does it look like? Trinomial has to have 3 terms. Difference of squares has to be 2 perfect squares with a subtract sign in between. Does that match that? Yeah. Okay, what times what is 4? What times what is x to the 4th? What times what is 81? And then what do you do with the signs? Plus, minus. 2 marks. Okay. Okay. First step, check for GCF. Is there a number other than 1 that goes into 12, 14, and 6? 2. So this time I can do a GCF. Okay. Now let's check for letters. x3, x2, x. Do they have an x in common? What is the smallest x that they have in common? Just x1. So we're going to divide everything by 2x. So 6x squared, 7x, 3. Now, that will give you 1 mark, okay, for finding the GCF. However, you are not done. You now have to take a look at that second bracket. Does the second bracket look like a trinomial, or does it look like a difference of squares? Trinomial. So now, look at the A. A does not equal 1. So we are going to do a tic-tac-toe. So we've got 6x squared in the middle, negative 3 in the bottom right, and then negative 7x. We leave that till the end. Now again, I'm going to focus on the 3, because there's only one way to multiply to get 3, and that's 1 times 3. There's a couple ways to multiply 6. Let's try 2 times 3 first. What number should I put on this side? 2, because you don't want to line up a 3 and a 3. So 2 and 3. So if this works, fantastic. So 3 times 3 is 9. 1 times 2 is 2. So right now 9 plus 2 is 11, but I can absolutely get out negative 7 if I do what? Which one would I make negative? Negative 7, the 9. Now, where should I drag this 9 to, the negative 2? Should I drag it out or should I drag it up? Out. Now do a quick check. Is 2 times 3 6? Is negative 3 times 1 negative 3? Yep. So the final answer, bring down the GCF, then put in your squares. So this question would be worth 3 marks because you found 3 brackets out of it. Okay. Okay. Last question. First thing we do is check for GCF. What is the biggest number I can take out of 32 and 72? You may need to use your calculator for this. Not 6. Is there anything bigger than 8? No, I think 8's the biggest. Okay, can I take out any letters? Can I take out an X? Nope. So, divide everything by 8. Is that 9? Yes. Okay. So now, just like here, we looked at the second bracket and saw that it was a trinomial. What does this second bracket look like? Difference of squares. Okay, so keep the order the same. What times what is 4x squared? 2x and 2x. What times what is 9? And then you make 1a plus, 1a minus. Guys, bring the 8 down. So again, that question is worth 3 marks. So on your exam, listen. Your exam will simply say, so question number 1 on your final is multiply the following. There's going to be like 4 questions on the page. Question number 2, factor the following. 4 questions on the page. And you will have to know what methods to do when. Okay, because it's all going to be jumbled up like that. So those are the first 2, that's the first page of your final. Okay, we're going to do one more thing, and then we'll stop. And that is simplifying radicals. So when we did simplifying, we did 3 types. We did entire to mixed, mixed to mixed, and mixed to entire. We are only going to do the first 2. We're going to do entire to mixed and mixed to mixed. Now, the first time we did radicals, I only showed you one way to do them. The second time we did the radicals, I showed you 2 ways to do them. So, we're going to go through both ways. Option number 1. So what you're trying to do is take this number here. This is called the radicand. And you're trying to make it small. You're trying to reduce it down in size. So method number 1 was stacking. So you take the 216. Now, there's one caveat with stacking. What kind of numbers can you only use here? Prime. So your prime numbers are 2, 3, 5, 7, 11. Okay? So I'm not allowed to divide by 8 or by 10 or by 25. Those are not allowed. Okay? So since it is even, what am I guaranteed will work? 2. So using your calculator or your brain, 216 divided by 2 is 108. Since it's even, I'm going to stick with the 2. I get 54. 54 is even. I'm going to stick with the 2. 27 is not even. So what is my next prime that goes into 27? 3 goes in 9 times, and then 3 goes in 3. Once you're finished with a prime number, you know your stack is done. So what we then do at this point is we look for our twins. So I've got a twin here, and I have singles here and here. So the way we did this is you go twins times singles. So each twin got its own house, and the singles were put in a house together. So this twin got its own house, this twin got its own house, and the singles got put in a house together. Now, what do you know about squares and square roots? They cancel off. So what I'm left with is 6 square root 6. So that was method number 1. Method number 2 was using what we called perfect squares. So the second method, while it is shorter, you have to know your perfect squares. So if you can count on your fingers, you can find the perfect squares. So in your brain, you're going to say 1, 2, 3, 4, 5. But on your page, you're going to think 1 squared, 2 squared, 3 squared, 4 squared. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. Now, using your calculator or your brain, you must find the biggest number in the list that goes into 216. So it has to be a number from that list. So on your calculator, you would go 216 divided by 4, 216 divided by 9, 216 divided by 16, and you would keep going until you found the biggest one, which just so happens to be 36. Now, when you go 216 divided by 36, you get out the answer of 6. Now all you have to do is one more step. What is the square root of 36? 6. And then you just bring this down. Same answer. Okay? So the perfect square way is a lot faster, but you must use the largest perfect square. That is the condition on that question. Whereas with stacking takes a little longer, but it's almost like you get to turn your brain off because you're just working with much smaller numbers. Okay. Now the other question is what happens if I stick a number in front? Essentially, it does nothing until the very last step. So we're going to ignore it until we get all the way to the end. So 375. If I did stacking, sorry? Yeah. What's the prime that you would use to go into 375? I'd probably pick 5. So that's 75. What's a prime that goes into 75? 5. What's a prime that goes into 15? 5. Okay. So we have got a twin set, and we have got a couple of singles. So the twins go into a house. The singles get put together. So for the twins, the square and square root cancel out. And these stay trapped inside. Now, all you have to do is remember about this 8. You're just going to take the 8 and bring it back. So the final answer is 40 root 15. For the perfect square way. So on this list of numbers here, which one do you think will go into 375? 25. So on your calculator, go 375 divided by 25. You should get out of 15. What is the square root of 25? 5. Bring down the 15. And then again, all you have to remember is to bring the 8 down. Now the final thing I'm going to say, the final thing I'm going to say is you can check all of these on your calculator. For the radicals part of the final, there is absolutely no reason why you should be handing me in wrong answers, because you can check everything. So 8 square root 375. Okay. And 40 square root 15. Same decimal. If you don't do it right, you won't get out the matching decimals. Okay, and it's pointless handing in something wrong. So you can check every single one of these using your calculator. I don't want to see the decimal anywhere on your page, but you are doing it as a means of checking. Okay, tomorrow when I see you, tomorrow we're going to keep on going with radicals, and we're going to do the adding, subtracting, and multiplying. So tomorrow's lesson will be a little bit shorter, so you'll have more study time tomorrow. But let me just get this thing stopped.